Hello everyone and welcome to Mathematics Schooling. Well, I'm posting the video after a long time as I was really busy with the preparation of the courses that we have already launched on our app, Mathematics Schooling. I was actually racing against the time to deliver more number of courses than what I have promised my students in the stipulated time. And that is the only reason I was little away from YouTube. Well, in this video, what I'm going to share with you is a question from the topic permutation and combination. The question is almost similar to the one which we already take in our permutation and combination course for JEE Advanced, but with a little, or I would say that slight modification. Let me clarify that this is a question from a previous math tournament that I'm going to share here, that I'm going to share or I'm going to discuss here. Let us read the question and solve it. So let's start. The question says that there are 2021 light bulbs in a row, labeled 1 through 2021, each with an on and off switch. They all start in the off position when 1011 people walk by. The first person flips the switch on every bulb. The second person flips the switch on every third bulb. That is 3, 6, etc. The third person flips the switch on every fifth bulb, and so on. In general, the kth person flips the switch on every 2k plus 1th light bulb, starting with the bulb 2k minus 1. After all 1011 people have gone by, how many light bulbs are on? So, well, what is the question? First of all, we'll have to understand what they are trying to say. So, they are trying to say that there are total 2021 bulbs. Okay? 2021 bulbs are there in a row, and we have 2021 switches in a row, each with an on and off switch. This is what they are saying. They all start in the off position. That means all the light bulbs or the switches of the light bulbs are in the off position. Now, the very first person will enter and he's going to switch on all the bulbs. Okay, all the bulbs he's going to switch on. Jitne bhi bulbs hain, un sabko switch on kar diya. Now comes the second person. This was for the first person. Now the second person comes. And now the second person is going to start with the 2k minus 1. 2k minus 1 means what? Because you are talking about the second person, he is going to start with the third bulb. And every 2k minus 1th position per jo light bulb hai, uska switch ka position he is going to change. That means second person is going to start with the third bulb. And now because it was on, it was switched on by the first person, he is going to switch it off. Then he is going to switch off the sixth bulb, and any multiple of 3 that he's getting, he is going to switch off that bulb, right? Then comes the third person. Now the third person is coming. Third person is coming and he's going to start with the switch at the 2k minus 1th position. What is the bulb at the 2k minus 1th position? So because k is 3 now, he's going to start with the fifth bulb. He's going to start with the fifth bulb and he's going to change the position of the switch of the fifth bulb. So you can see that right now the fifth bulb is on. So third person will come and he's going to switch off the fifth bulb. Then coming to the fifth ke baad, the 10th bulb. 10th bulb ki position again he is going to change. So because it is still switched on, because previously when the second person came, he was switching off the switches which were the multiples of 3. And 10 is not a multiple of 3, so it was still switched on. So the third person aa raha hai, he's switching off this bulb. And he keeps on doing it like this for every fifth bulb. That means all the multiples of 5 will be operated by this particular person. So the same process keeps on continuing till the last person. Who is the last person who is going to come? The last person will be 1011th person, and he is going to start with the bulb. Which bulb? 2k minus 1th position wala bulb, which turns out to be 2021. So he is going to change the position of this bulb, right? If it is on, then he is going to make the switch off, and if the switch is off, he is going to make the switch on, right? So this is what is happening in this question. Now what they are saying that at the end of this whole process, that means after all the 1011 people have gone by, how many light bulbs are still on? How many light bulbs are on? So, okay, first of all, we will have to check how many light bulbs are going to be on at the end of the process. This is the question that is what we want to solve. But just have a general look at the question. It is very much clear that because initially all the switches were off, The very first operation of the switch will make the bulb on, right? Second operation of the same switch will make the bulb switch off. Third operation will make the bulb switch on. So I can say that a particular switch, if it is operated odd number of times, then ultimately the bulb is going to be in the on position, right? If a bulb is operated odd number of times, the bulb is going to be in the on position. But if it is operated even number of times, then ultimately the bulb is going to be in the off position, right? If you are operating odd number of times, the bulb will be on. Why? Because the switch will be on. First operation on, second off, third on, fourth off, fifth on. So suppose 5 times a bulb switch is being operated. So ultimately the bulb is going to be in the on position. So this is the first observation that we have made, that any particular switch, if it is operated odd number of times, then definitely the bulb is going to be in the on position. Now the second observation. The second observation that we are going to do here is, sorry. So second observation is, a particular bulb is being operated according to that information that they have given. That kth person will start from the 2k minus 1th bulb. And he will keep flipping the switch at every 2k minus 1th position, right? A odd number say he is starting, and at a difference of odd number, he is flipping the switch, right? This is what they are saying. So can I say that whatever switch you are operating, whatever switch that we are operating is going to contain odd number as its factor. Like here you can see that we are switching off the bulb or the switch which is at the third position. It is a multiple of 3. Sixth position having 3 as a factor. And similarly, we can say that at the end 2021, so we can say that 2019, right? 2019th wala switch will also be operated by this person. So I can say that a particular switch will be operated if it is a multiple of some odd number, right? A particular switch will be operated if it is a multiple of some odd number. If it is a multiple of some odd number, then definitely it will be operated. Fine. So अब ये दो observations है जिनकी help से I'm going to solve my question. What I need is, first thing that we have observed is that each switch that we are considering here will be operated odd number of times. Then only the bulb is going to be in the on position, right? Whatever switch is being operated odd number of times, that particular bulb is going to be in the on position. Second observation जो हमने यहाँ पर किया है वो ये है कि any particular bulb will be operated only if it is a multiple of some odd number. If it is a multiple of odd number, it will be operated. If it is only a multiple of even number that is not containing any odd factor, then that switch will not be operated, right? For example, if I talk about 16, so 16 कहाँ operate कर पाओगे? Why? Because first person ने operate किया, 16th switch को on कर दिया. It is being operated only once. After that, second person के लिए we are going. If you are going for the second person, then you can see that second person is not going to operate the 16th switch. What do you say about the third person? No. The fifth person, the fourth person? No. Because all of them are going to operate the switch which is a multiple of some odd number, right? So from these two observations, one thing which is clear is if any particular light bulb is left on, it means that that particular bulb के corresponding जो number है ना, the number which is corresponding to that particular bulb must have odd number of factors. First of all, it must have odd number of factors, and not just odd number of factors. It must have odd number of odd factors, right? It must have odd number of odd factors. So if it is something like, if it has odd number of odd factors, then only the particular bulb is going to be in the on position. Otherwise, it will be switched off, right? Otherwise, it is going to be like a switched off position. Now, my question is, what numbers do have odd number of factors? Which all numbers do have odd number of factors. So whatever the switch or whatever the number is associated with the bulb or the switches, if that particular number has odd number of factors, then definitely it will be operated odd number of times, right? Odd number of times. And secondly, it will be having odd number of odd factors as well, right? It will be having odd number of odd factors. For example, let me just show you that any number which is a perfect square, right? Any number which is a perfect square is definitely going to have odd number of factors, and it will also have odd number of odd factors. This is what we are going to see. So देखो factors क्या होते हैं? 2 into 3 into 5 into 7. These kind of factors we have, right? These kind of factors we have, but this is not a perfect square. And also the number of factors that it has is 2 into 2 into, the index is 1 na? So 2 can be taken in 2 ways, 3 can be taken in 2 ways, 5 can be taken in 2 ways, 7 can be taken in 2 ways. So total it has 16 factors. This is not my answer, right? A particular number having 2, 3, 5, 7 as its factors, or the number is 2 into 3 into 5 into 7, then definitely it will not to be operated odd number of times. The numbers which are operated odd number of times are the perfect square numbers, and these are the numbers which have odd number of odd factors. Kaise? Suppose I have 2 raised to the power 2. I'm having 3 ka square, 5 ka square, 7 ka square. Any particular number which is a perfect square, I have taken just an example here to explain it to you. Now we know that it is a perfect square. How many factors will it have? Total 3 power 4. If I say how many odd factors does it have, the answer is going to be 3 cube. Correct? It is going to have 3 cube odd factors. So this particular number is a perfect square. Why? Because I want the odd factors which can come only when odd number of factors ka index is something like E1. It definitely has odd number of odd factors, right? So total factors that we have here are odd. Further, odd number of odd factors also we have here. Yani basically, if you want a switch to be operated odd number of times, then the number associated with that particular switch must be a perfect square, or it can also be 2 times the perfect square. Now, let me explain why I'm saying 2 times the perfect square. First of all, perfect square में भी हमने condition क्या लगाई है कि perfect square में the important thing is it should be a perfect square, absolutely fine, but it must have odd number of odd factors. उसमें जो number of odd factors होंगे, that must be odd. So I can say every perfect square satisfies this condition. Every perfect square satisfies this condition. Because even if I take some perfect square like this, na, 3 square into 5 ka square, it does have how many factors? 3 square. How many odd factors? 3 square. If I say the number is 2 raised to the power 4, how many factors does it have? 5. It is a perfect square number and it has odd number of factors, right? But how many odd factors does it have? It has 1. So every number which is a perfect square is definitely going to have odd number of odd factors. So what I want in my question, if I want a light switch to be on, then it must be associated with the number which is a perfect square. The first thing that I told you is this one. And secondly, the condition is it must have odd number of odd factors. Okay? It must have odd number of odd factors. So what I'm saying is that every perfect square will definitely have odd number of odd factors every time. So what I'm going to do, first of all, I'm going to count all the switches which are having the number, a perfect square associated with it. But apart from this, I'm also saying that twice of perfect square is also absolutely fine. Why twice of perfect square is also absolutely fine? Because let me show you. If I consider 2 multiplied by 3 ka square multiplied by 5 ka square, then what I want in my question is the switch must be operated odd number of times. Okay? And it must have odd number of odd factors. The important thing is odd number of odd factors. How many number of factors does it have? Number of odd factors that we are counting here is 3 ka square. So what did I say? Every perfect square satisfies this condition that it will have odd number of odd factors. And further, a perfect square multiplied by 2 will also be satisfying this condition that it will have ultimately odd number of odd factors. See, why we are not worried about the even factors? Because none of the switches being operated as a multiple of some even number. Whatever switch you are operating is going to be multiple of some odd number. It might be possible that 3 into 4 you are doing, but we are looking at that switch as if it is a multiple of 3, right? So that's why odd number of factors are important. Odd number क्यों important है? Because the switch is to be operated odd number of times. Why the multiples or the factors of odd number are important? Because each switch will be operated as a multiple of odd number, or that switches, or we can say that all those switches will be operated which are going to be the multiple of some odd number. So important part kya hai? We want in the question that the switch, because we want the switch to be or the bulb to be on at the end of the process. That's why we want that particular switch is to be considered. That particular bulb is my answer, which is going to contain the number which will be having odd number of odd factors. All those switches, the numbers associated with them are such that they have odd number of odd factors is going to be my answer. And I have interpreted from here that what I'm going to consider is all the perfect squares I will take. And secondly, along with all the perfect squares, I will also be taking the number which are twice of the perfect squares, right? Well, we have a constraint over here कि कितने perfect squares ले सकते हैं, because they are saying that the switches bear the number 1, 2, 3, 4 and the maximum is 20, 21. So how many perfect squares numbers we will be having here? How many switches are going to be like the perfect square? So I'll say that it is like 1, then I'll have 4, then I'll have 9, and the maximum that I can have. See, 45 का square is 2025, which is actually crossing this, right? 2021 के आसपास जो भी perfect square था, that was 2025, and we know it is 45 का square. So I said 45 का square, so I'm not getting. So the last number that I'm getting here is 44 का square. 44 square. So let me write 4 also as 2 ka square, 3 square and 44 square. Like this, I am able to at least count that there are 44 such switches which bear the number which is a perfect square, and hence it has odd number of odd factors. But as I told you, I will also be counting those switches which are containing the number which is equals to twice the perfect square. Twice the perfect square means now I'm going to consider the answer 2. Then I'm going to consider 2 cube, and I'm going to consider 2 into 3 ka square, and I'm also going to consider 2 into 44 ka square. Is it possible to count 2 into 44 ka square? The switch containing the number 2 into 44 square will cross 2021, right? We don't have a switch bearing that particular number. Which number? This number. The maximum number that we have for the switch is 2021. So that's why now we will have to think which number or which particular switch is going to be the last switch having the number of this kind. So I said 30 ka square jo hota hai na, that is 900. So 2 into 30 square is absolutely fine. We don't have any problem. We have reached up to at least 1800. What is 31 ka square? It is 961. So I said, okay, fine. Let's check for 31 ka square as well. When you calculate it, you are getting 1922. Then I said, okay, fine. Let us check 32 ka square as well. What is 32 ka square? It is actually 2 power 10 multiplied by 2. So it is turning out to be 1024 into 2, that is 2048. It crossed the number 2021. It cannot be my answer. We don't have any switch bearing this number. So obviously, I'm going to say that 31 such cases I'm going to get, which are of the type, or which are the switches bearing the number 2 times a perfect square. So these are total switches which are ultimately going to be in the on position. Or we can say that total number of bulbs which are on at the end of the whole process will be 44 plus 31. So what is the answer we are getting over here? The answer turns out to be 75. There are 75 bulbs which will be in the on position at the end of the process. Fine. So this is the answer. And that's all in this question. Hope you enjoyed this amazing interpretation that we have done and how we have utilized this information, the information of number of factors from permutation and combination to solve this question. So if you enjoyed this question, then do share it with your fellow aspirants, with your friends. Help us increase our subscribers base. See you in the next video. Till then, take care and bye-bye.